In this video we're looking at section Seqr D. In this section we're looking at application problems, so problem solving of arithmetic sequences and series. Now arithmetic sequences may arise in many practical situations, and it's going to be whenever something is increasing or decreasing by a constant amount, that constant difference. Now in these situations we can use our definitions of arithmetic sequences and we can use our formulae to simplify the problem and determine solutions without the need to list the entire sequence. If you do list the entire sequence to answer a question, you will not receive full marks. So our first question here, how many multiples of 6 lie between 200 and 500? So we're going from this 200 up until, 550. So what's our first multiple of 6 after 200? Use your calculator and you'll find that the first one is 204. So our next number must be 210, then 216. So we're going up by 6 each time. Up until what? Well, what number before 550 can be divided by 6? Again, use your calculator and you'll find it's 546. So from here, our first term is that 204, our common difference is 6, and our nth term is 546, and we want to know what n is. So let's write out our formula for our general term, and we can substitute in. 546 equals 204 plus m minus 1 times 6. Take 204 from both sides because you're trying to isolate that n minus 1. Okay, so 546 minus 204 gives you 342, and you've got n minus 1, 6. Let's expand that out. 6 times n, 6n, 6 times -1 is -6. Add 6 to both sides. 342 plus 6 is 348 equals 6n. Divide both sides by 6 and you get that n is 58. Okay, finish with a therefore statement, which will be there are 58 multiples of 6 between 200 and 550. Next, a part-time employee is employed for $2,100 per month, but at the end of each month she receives an increase of $50 a month. So if you think about this in terms of an arithmetic sequence, we've got 2,100, 2,150, 2,200, 2,200. I keep doing the same thing, 2,200, 2,250, and you keep going. Okay, in which month will she earn 3,000? Now I don't want to keep listing them to work it out, I want to work it out mathematically. So I know that A1 is 2,100, I know my common difference is 50, and again I know that my n term is 3,000. Okay, so let's solve this. an equals a1 plus m minus 1d. So this is exactly the same as the previous question. So pause the video, have a go yourself, okay? Make sure you know how to work it out. Just don't keep following my solutions. Subtract 2,100 from both sides. I'll expand this out at the same time. 50 times n is 50n. -1 times 50 is take 50. Add 50 to both sides. 950 divided by 50 is 19. Okay, therefore write a statement. So you've got in a 19th month she'll earn $3,000. Now no, at the end of that 19th month it will actually be $3,050 because it says it increases at the end of each month. Okay, but actually in that month she'll receive that 3,000. Next, what will the employee earn in her 12th month? We've got the same sequence. What we want to find out now is what A12 is. Okay, so AN is A1 plus n minus 1d. Substitute in. A12 is going to be 2,100 plus 12 minus 1 times 50. So we get 2,100 plus 11 times 50. Plug that into your calculator and you get $2,650. Write your therefore statement. Okay, so you've got she earns 2,650 in a 12th month. At the end of that month is when it'll go up to 2,700. Now, with many arithmetic sequence applications, it's necessary to calculate sums of terms. So we're going to be looking at the series. So in these cases, formulae for series can be used to determine the solutions. So let's look at our first question here. It says find the sum of the first 50 even positive integers. Now, I'm sure you wouldn't want to try and do this by hand. So if we're looking at positive integers, we're looking at 2, 4, 6, and it keeps going. So our first term is 2, and our common difference is 2. It says the first 50, so that means n is 50. But it's asking for the sum. So I don't just want to work out my term, I want to work out the sum of the terms. So in order to do that, I need to use one of the formulas for my sum of terms. So if I write one of those out, so S of n equals n a1 plus a2 all over 2. So that was one of my sums of formulas. The other one was S of n equals n over 2 2a1 plus n minus 1 d. Now if I look at what I've got my common, this should be a1 plus an. Sorry about that. All over 2. Now what have I got? I have a1, I have n, and I have d. Here I don't have what an is, so this second formula is probably the easiest one to use. So I've got, you would work down your page yet again, so S of 50 would be 50 over 2, 2 lots of 2 plus 50 minus 1 times by 2. 50 divided by 2 is 25, 2 times 2 is 4, plus 50 minus 1 is 49 times 2. That becomes 25. 4 plus 49 times 2 is 98. So I've got 25 times 98 plus 4 is 102, which gives me 2,550. Again, finish with a therefore statement. So I have the sum of the first 50 positive integers is 2,550. Now in the textbook they actually use this formula here. But as I've shown you, you had all the information for this second one. But look at that for an alternative. You'll see you get the same answer. Okay, another one. This is the same question as we were looking at before with a part-time employee. So a part-time employee is employed for $2,100 per month, but at the end of each month she receives a $50 increase. What would be the employee's annual income for her first year of employment? So we're looking to add things up. So I know my first term is 2,100. I know my common difference is 50. And for an annual income, what I want is that S12. Okay, the sum of the first 12 terms, so n is 12. So let's write out our formula. S of n equals, and in this case we might use the same formula as we used in the first problem, or we could use the other one, but I think we've got everything for that formula that we used previously. So n over 2, 2a1 plus n minus 1d. There we go. So let's plug everything in. So I've got n is 12 over 2, 2 times 2,100 plus n is 12 minus 1 times 50. So that becomes 6. 2 times 2,100 is 4,200 plus 11 times 50. Simplify that out. 4,200 plus 11 times 50. I get 4,750, and I times that by 6, and I get 28,500. Again, finish with a therefore statement. So you have, therefore, the employee would earn $28,500 in her first year. Second question, for how many months must she work to earn a total of $36,750? So in this case, again, I have my first term is 2,100, and my common difference is 50. I want to know what the n is when S of n is 36,750. Okay, so again, write my formula out. S of n is n over 2, 2a1 plus n minus 1 d. Plug in everything. 36,750 equals, I don't know what that n is. I have 2 times a1. It's like I'm going to run out of room, doesn't it? N minus 1 times 50. So I'm going to times both sides by this 2 to get rid of this fraction. So 36,750 times by 2, I get 73,500 equals. Now I'm going to try and neaten up what I have in this bracket. So I've got n. 2 times 2,100 is 4,200. I can expand this out. Plus 50n minus 50. 73,500 equals n. 4,200 minus 50 is 4,150 plus 50n. I'm not even going to say the numbers when I stuff it up. Expand 4,150n plus 50n squared. Get everything on one side where the n squared term is positive. Okay, so I've got that. Probably divide everything by 50 would just make it even simpler. I get plus 83n minus divided by 50 becomes 1470. Okay, use your quadratic formula. I'm not going to go through that here because you already know how to do it from the quad module. Okay, so stop the video, use your quadratic formula. You'll end up getting that n equals 15 or n equals negative 98. You can't have a negative, so its n is 15. Finish with a therefore statement. Okay, so the therefore statement is, therefore she will need to work 15 months in order to earn that 36,750. Sorry, it's a little bit cramped there, but you get the idea. So what now? Practice time. Seqr D1 and Seqr D2. So there's 2 exercises in there that are just on application problems. This one here is on sequences and this one is on series. Good luck.